So for this problem, we are trying to use Mohr circle to find out the principal moment of inertia for this cross-sectional area. So the first step, we need to calculate the moment of inertia around xy axis and ixy. However, this problem is already given, which means we can calculate the center of the Mohr circle is equals to ix plus iy divided by 2. So for our problem, the center of the Mohr circle is 5608. So which means what we're going to do is try to find the center of the Mohr circle first. So this is the center of the Mohr circle. And then on the Mohr circle, we can try to find a point on the Mohr circle will be ix, ixy, and then we have to find the x location, so which is 29, -30. So it will be somewhere here. So we had the center of the Mohr circle, the point on the Mohr circle, which means we should be able to draw. So this is x location. It's the center of Mohr circle. So now you can see on this Mohr circle, where is the maximum moment of inertia is the farthest point we can reach here. And then on this end, that's going to be the minimum moment of inertia we can find. So take a look at the Mohr circle. You can see the maximum moment of inertia will be this length. It equals to the center of the Mohr circle plus the radius. So which means we have to find out the radius of Mohr circle first. How we are going to find out the radius? We always use the OX line to construct a triangle. You can see in this triangle, the radius of the Mohr circle is the hypotenuse. So that's why if we can find the base and the height, then we take the square root. We can find out the radius of the Mohr circle. So what is the height of this triangle? It's actually just the y distance for the x location. Okay, so now we have to find out what is the base length so that we can calculate the hypotenuse. So now you can see from the geometry, you can see the base of the triangle is equals to the center of the Mohr circle. Take off the distance of x, 7, and the height ixy is 36. So finally we find out the radius of the Mohr circle is going to be 45. So now, based on the geometry, we can see the maximum moment of inertia is equals to the center of the Mohr circle plus the radius. So the minimum moment of inertia is equals to, you can see this distance is going to be the minimum moment of inertia. So that's going to be the length, the center of the Mohr circle minus the radius. So the next thing we are going to do is how we are going to rotate our original axis to get the maximum moment or the minimum moment of inertia. So what we have to do is try to figure out what's this angle. So normally we call this theta P2 because it's to the minimum moment of inertia. Okay, so now in this triangle we can see tangent to theta P2 is equals to the height, which is ixy divided by the base, 27. So which means we can find out 2 theta P is equals to 53.13 degree. So which means the rotation of the coordinate system, that's going to be half of this angle. So now what we can do is try to rotate our original coordinate system to the principal axis. So now you can see X line on the Mohr circle is going to be the OX line here. So if we rotate clockwise, that angle we are going to reach to the minimum, which is the minimal principal moment of inertia. So which means we are going to rotate in the same direction but half of the angle clockwisely, 26.56 degree. We are going to reach to the minimal moment of inertia. And then if we keep rotating 180 degree, we are going to reach to the maximum moment of inertia. So for the same Mohr circle, what we are going to do is try to rotate the axis clockwisely 20 degree. So what does this mean? It means that originally this is going to be our XY axis. What we are going to do is try to rotate the whole coordinate system clockwisely 20 degree to a new axis, U and V. So what we are going to do is try to use the Mohr circle to solve this problem. Always remember OX line is represents your x-axis. So you can see your x-axis rotate clockwise 20 degree, which means I am going to rotate OX line in the same direction but double the angle. So which means the total rotation here is going to be 40 degrees. So what I have to do is try to find out on the Mohr circle what is the x prime point location, and this is going to be IU and IUV. So now let's take a look how we are going to use geometry to solve what is IU and IUV. We are going to construct a triangle. So you can see if we know the angle alpha here, then we already know the hypotenuse, right? That's radius of the Mohr circle. So we use hypotenuse multiply sine alpha, that's going to be IUV. So which means the key is try to find out the alpha first. So what is the alpha? Remember, when we try to rotate OX line to the horizontal line here, that's called the principal angle, right? We just do the calculation. 2 theta p is equals to 5313, which means from OX all the way to the horizontal axis. Now, how we are going to find out the alpha? You can see that's going to be 2 theta p minus 40 degree. So which means we had 1313 here. So as I explained, the IUV is going to be the green line, which is the radius of the Mohr circle, and then multiply sine alpha. However, take a look at this green dashed line here. It is in the negative IXY region. So which means we have to add a negative sign. Okay, so now what we have to do is find the IU. So what is the definition of the IU? It means that from the origin to this point, this is going to be the IU. So take a look at the geometry. From the origin to the center of the Mohr circle, if we take off the base for this green triangle, that's going to be IU. So which means IU is center of the Mohr circle minus the base here. So now we find the IU, IUV. The only thing we don't know is going to be IV. What is IV? So take a look at here. U and V are perpendicular to each other, which means on the Mohr circle, what we are going to do is rotate OX prime line, double the angle 180 degree, which means we just extend this line and the intersection here, that's going to be Y prime IB negative IUV. So now how we are going to calculate IUV, we always go to the geometry. So you can see from the origin to this point, that's going to be IB. How much is that? You can see based on the geometry, it is equals to the center of the Mohr circle plus the base of this red triangle. And this angle is going to be equal, so which means IB is equals to the O plus R cosine alpha.